I'm Sienna Bose. Welcome to my channel, Learning Builds Life. Today we are going to begin a new series in Campbell Biology, which is the chapter, The Chemical Context of Life. And the topic we are going to discuss about today is matter consists of chemical elements in pure form and in combinations called compounds. Okay, let's start. Firstly, what is matter? The definition of matter. We know that matter makes all living things. All living things are made up of matter. But what is matter? Matter is something, is anything. That occupies space and has mass. Matter is anything that occupies space and has mass. That is matter. Now, we will talk about it consists of chemical elements in pure form and combinations called compounds. We will discuss about elements and compounds. This is the elementary stuff in chemistry. Elements and compounds. What are elements? Elements are pure because they exist in pure form, because they cannot be broken down into any more pieces, like they're indivisible. They cannot be broken down. Be broken down. Scientists have found 92 elements found in natural occurrences, means naturally found elements. 92 elements, which are naturally found. Some examples are gold, copper, oxygen, and carbon. Those are the 92 elements. Means in those 92, these are 4 examples. Now, what are compounds? Means firstly, elements have symbols, which are made up of the first letter of that element. Like for carbon, it's C. Carbon, C, which is having the first letter. Or it can have any 2 letters, the first letter and any letter from the word of that, it means for the word of that element. And also, some symbols are derived from the Latin names. Like sodium is Na from the word natrium, that is Latin for sodium. It has 2 letters, the first letter and the second letter of the word natrium. Now, that was about elements. We will move on to elements in life, but first we will discuss about compounds. So compounds are made up of 2 or more elements. Made up of 2 or more elements. One very common example is common salt, NaCl, that is made up of Na that is sodium, and Cl, that is chlorine. But there is a special thing over here. Means actually, it's in the 1-to-1 ratio. But the peculiar thing is that pure sodium is a metal. Just a minute. Pure sodium is a metal. And pure chlorine by itself is a poisonous gas. And when they are in the 1-to-1 ratio, they form NaCl, which is edible common salt. NaCl, common salt. This tells us that compounds don't retain the properties of the elements that form them because sodium itself is a metal and chlorine itself is a gas, but NaCl, which is made up of sodium and chlorine, is common salt. Similarly, H2O is formed from hydrogen and oxygen. H and oxygen. O. Here also both are gases, but they form a liquid. And it's in the 2-to-1 ratio, hence H2O, that is water. This was all about elements and compounds. We will move on to elements of life, but first you may take a look at the board. Moving on to elements in life. We are continuing with elements of life. Elements of life. We have just talked about elements and compounds, in which we came to know that there were 92 elements which were naturally occurring, naturally found. Out of those 92 elements, 20 to 25% of elements are necessary for living beings, living organisms is a better word. Necessary for living organisms to survive. 20 to 25% of 92 elements which were naturally occurring. Now, but there are some variations, like for example, in humans, we need 25 elements. But for plants, we need 17. I'm not writing that down. For humans, we need 25 elements, but for plants, we need 17 elements. That's a little bit of a difference, but basically 20 to 25% of those 92 naturally occurring elements are necessary for living organisms to survive. Now, talking about humans, the four main elements, which are carbon, oxygen, hydrogen, and nitrogen. I've just written the symbols, but I'm just telling that again. Carbon, oxygen, hydrogen, and nitrogen. This makes up 96% of the body mass. Approximately 96%. And the rest of the 4% is made up of some merely available elements in the body, merely found, like in case of phosphorus, potassium, sulfur, and calcium. That makes up 4%, approximately 4% of the body mass, and together 100% of the body mass. The main elements are carbon, oxygen, hydrogen, and nitrogen, and some, like not trace elements, but they are necessary for survival as well, but they're found in lesser quantities: phosphorus, potassium, sulfur, and calcium. And lots of trace elements, but they are in very less percentages, like less than 0.01% in the body. Those are also necessary in very small amounts. Like, for example, iron. Fe, iron, comes from the word ferrum, Latin. Fe, iron, that is one of the very important trace elements. And another very important for vertebrates, that means those organisms which have a backbone, they are called vertebrates. That is iodine. Iodine is very important. It's a very important trace element because it keeps the thyroid gland in our body healthy. The thyroid gland. Which is a butterfly-shaped gland found in this area. That is the thyroid gland. To keep this gland healthy, we have to consume at least 0.15 milligram of iodine in our balanced diet daily. This will keep the thyroid gland healthy, and since we have the intake of iodine can be from seafood or iodized salt. These two foods have a lot of iodine, which can help to fulfill this intake. But iron deficiency, that means the lack of iron in our body, can lead to a disease, a deficiency disease called goiter. In this disease, the thyroid gland swells up abnormally, which leads to an increased, like a very swelled up neck. That is, the swelled up thyroid gland swells up due to the deficiency of iodine. So make sure to take adequate iodine in your balanced diet. It's good to have a balanced diet, but also it should contain iodine so that this does not happen, goiter. Another thing which scientists have discovered is that an element which is naturally occurring only, that is arsenic, has some dreadful consequences if it goes inside our body. It was found mainly in water. Indirectly, people have consumed arsenic and have shown some very dreadful consequences have happened to them. It's a deadly poison, actually. It's found in water. Many people in South Asia have had arsenic from groundwater. Groundwater have the arsenic. So people are trying to improve the soil quality so that it doesn't have arsenic-laden water. This was all about elements of life. Next, we will cover a topic which is case study, in which we will see how some organisms are habituated to toxic environments, and toxic elements are there that lead to toxic environments, how those plants or animals can survive over there. That is a case study. But before that, you may take a look at the board. Moving on to our case study. Now we will continue with our case study. Our case study was about some species which could adapt to environments which consisted of elements which were generally toxic to living organisms. So, one example of this type of species is serpentine plant species. Serpentine plant species. Serpentine. What is serpentine? Serpentine is a jade-like, like jade-colored, jade-like stone. It's like a mineral. Now, serpentine, why is this toxic? Because it's an alloy type of an alloy of elements like chromium, nickel, and cobalt. Now, this is one information that I'm giving, is that chromium is considered carcinogenic for humans. Like some faucets or taps, they have like a chromium coating that is like sort of carcinogenic for human beings, and also nickel and cobalt are a type of toxic. Anyway, hence serpentine is a jade-like mineral which is toxic. Now, with this plant species can tolerate, means it can stay in these toxic environments where serpentine mineral is hugely found. It's like in abundance over there. The one example of the plant is the Mariposa lily, which is found in Tiburon. Mariposa lily. But how is this resistance developing? Previously, we have studied about natural selection and evolutionary adaptations. It's possible that it could be like some non-serpentine plant species could survive in these serpentine environments, because of which then subsequently, when the natural selection occurred, then it led to this species, which is serpentine resistant. The serpentine resistant species could have been from a non-serpentine plant which could survive, and then after repetitive subsequently natural selection occurred, and then we got this species, that is serpentine plant species. And this is of great interest to scientists nowadays because it teaches us many aspects of natural selection and evolutionary adaptation. Natural selection and evolutionary adaptation. You can check out what is natural selection and evolutionary adaptation in my previous Campbell series. Go take a look at that series as well. It will tell you a lot about natural selection and evolutionary adaptation. And this Tiburon Mariposa lily is one of the examples of the plants in this species. Now you may take a look at the board. Hope you enjoyed this episode, and please like, share, and subscribe my channel, and stay tuned for more episodes. Thank you!